What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at something called 4.6 similar figures. So we're going to be able to identify what are similar figures, how can we use those to help us understand a little bit about how they work, and then name the corresponding sides and angles of the similar figures to hopefully determine what the missing sides could be equal to. The first thing we want to make sure of, we know what similar figures are. Figures are similar if they have the same shape but not the same sides. Their angles are going to be the same, but their sides will be proportional. For example, if you look at side AB corresponds to DE. And notice that 3 changes to 6 because 3 is exactly half of 6. If that's the case, that needs to be true for all other corresponding angles. So again, I start with the small triangle. The side 4 corresponds with the side 8, EF. 4, 8 is also reduced to 1/2. And then the final side that corresponds, 5, corresponds to 10, which also reduces to 1/2. One thing people get confused is if I start comparing the small shape to the big shape, I need to continue to use that same pattern. I could start and do big shape to small, but I can't do small to big and still have it equal. So if I start with 10 to 5, then I would need to then choose 8 to 4 because those are both big leading to small. Big leading to small, okay? This next question says, which rectangle is similar to rectangle A? And so what we want to do is we want to make sure that it is proportional to rectangle A. So right now rectangle A is 3 to 6. And if I'm going to compare like red to blue, I can say that is 1 to 2, okay? Which means I also have to come over here and compare my other reds to blues. My red to blue on rectangle B is 2 to 6, but that reduces to 1/3. But if I look at rectangle C, red to blue is 2 to 4, which reduces to 1/2. So it looks like rectangle A is similar to rectangle C. Okay. I can also just compare their matching and corresponding sides. For instance, if I wanted to say 6 corresponds to 4, that's a 3 to 2 ratio. 3 corresponds to 2, that's also a 3 to 2 ratio. And notice that those sides are proportional because their proportions or their fractions are simplifying to the same thing. Rectangle D is 3 units long and 1 unit wide. What rectangle is similar to rectangle D? That's going to be rectangle B. Just because rectangle B also has a 1 to 3 ratio, if I rewrote it and said this is 6, this is 2, 2 compares to 6 the same way as 1 compares to 3, or you can say 1 is exactly half of 2 and 3 is exactly half of 6. The following show that the figures are similar. Find x. So now what we're going to do is talk about how can we set up a proportion and solve those. One thing you might want to start looking at is 6 is relating to 9, much so 8 is relating to x. Let's go ahead and set that up. If 6 relates to 9, then 8 should relate to x. Notice I did 6 first over 9, so that means I should do 8 first over x. This was small shape to big shape. The next thing we want to make sure of is if we know how to solve proportions. These are very simple. You're going to cross multiply first. So I'm going to do 6 times x is equal to 8 times 9. 6 times x is 6x, 8 times 9 is 72. The last step I'm going to have here is just divide both sides by whatever x is attached to. So x is equal to 12. Okay? So with that said, why don't you go ahead and try this one? Why don't you try to compare the small shape to the big shape with their matching corresponding sides to try to find x. All right, hopefully you had a chance to try it. If not, pause the video one more time so you can try it, but let's go ahead and get started. What I did is I compared 6 to 9. 6 was from small shape, 9 was from big shape, so that means I'm going to also start from small to big, x over 6. Set it equal to as a proportion and go ahead and start cross multiplying. 9 times x is equal to 6 times 6. 9 times x is 9x. 6 times 6 is 36. Final step, I'm going to divide both sides by 9. So x is equal to 4. Okay. Again, another example to try. See if you can try this one. You can try to set up a proportion, but some of you might catch on right away and not have to set up a proportion for this one. All right, hopefully we got a chance to try. This one looks like we're going to compare big to small. So I'm going to start with 14 to 7. So big to small. 14 is on the big shape, that matches with 7. X is on the big shape, and that matches with 12. Okay. You can cross multiply here, but what I would recommend is I notice that 14 and 7 have a relationship. 14 is exactly half of 7, or 14 is exactly twice the size of 7. So that means x should be twice the size of 12. So I'm predicting that x should be equal to 24. Okay. What we're going to do first is, though, show my cross multiplying steps. So I'm going to do 7 times x is equal to 14 times 12. 7 times x is 7x. And 14 times 12, just checking my calculations, is 168. Final step, divide by 7. 168 divided by 7 is 24. So sometimes you don't necessarily need to use the proportion, but a proportion is always going to work. An artist draws a replica of a painting that's on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid is a replica of 3.75 inches. What is the height h of the trapezoid of the replica? So again, we're starting with big shape to small shape. So 15 matches to 3.75. So 12 is going to match with h. Let's go ahead and cross multiply. 15 times h and 3.75 times 12. 15 times 8 is 15h, but 3.75 times 12 is 45. Dividing both sides by 15, I'm going to get my answer. H is equal to 3. Okay,